All right. Hello, everyone, and welcome to Bayworks Virtual Training Buffet and to this session that's entitled Using Dashboards to Optimize Performance and Regulatory Compliance. For those who are not familiar with Bayworks, we are a consortium of water and wastewater agencies in the San Francisco Bay Area region and beyond. And we're working together to ensure we have a reliable workforce needed to serve our customers and protect our environment. Bayworks activities and programs and events are open to employees of all water and wastewater utilities. Please visit our website at baywork.org. Before we begin the session, I want to review a couple of housekeeping items. We want to invite you to post your questions and comments into the field. We will get to as many as we can near the end of the session. Also, this session will be posted soon on our website. At the end of the session, there will be a brief survey that we'll ask for you to fill out. We'll place that information, the link to it, in the chat. Also, we want to encourage you to change your view from gallery to speaker view. That way you can always always see our speaker. Now I want to introduce our speakers for today, Patrick and Ryan Shepard, to tell us about using these dashboards and stuff. I'll turn it over to you guys.
Thanks, Robert.
Yeah, thank you, Robert, for that introduction. Hey, everybody, my name is Patrick McGrath. I'm an operator with the City of San Luis Obispo's Water Resource Recovery Facility. I'll be talking about using dashboards for optimized performance and regulatory compliance with Ryan Shepard, founder and CEO of Databrook. We came together a couple of years ago, two years ago or so, as a collaboration between utilities and data science. And we just started to, one, identify some problems that data can help us solve, and two, see what kind of tools we can build to help operators meet their goals a little bit easier and more efficiently.
All right, so is the presentation come through all right?
Yeah, we see it.
Great, okay. So when talking about technology, it's easy to jump right in and talk about specifics. I want this chart to visualize this thing in this way. But for this, we want to start a little bit higher up. I think in any technology, when you're embarking on any technology endeavor, it's worth trying to get a little higher than those details and think about, what are we really trying to solve for here? And so Patrick and I talked about this early on in the project, and it's not trying to track chlorine usage or something like that. At one of the highest levels we could think of, we just want to know, how's the plant doing? So that was kind of our root question we were striving to answer.
And so as we talked a little bit about this, data scientist to wastewater treatment plant operator, one of the things that came together pretty quickly was something that should be pretty familiar to all of us. We just happened to put it together in a nice little circle of emojis. This is right. This is the operational cycle. And I would expect every plant goes through this. And it's typically conducted by facility staff, people. Right, and so Ryan will take us through steps, the first couple of steps.
Yeah, so trying to answer that question, how's my plant doing? You start out gathering data, and this isn't just looking at SCADA screens or getting lab samples back. A big part of it is being out there, walking around. You're listening for squeaky belts, or you're sniffing for septicity. So the operator is a key part of this process, and while some of these things are qualitative and won't be able to be tracked, there are other parts of this that can be automatically tracked, and where we can, we should start thinking about that. Once you've gathered that data, you need to figure out what it means, and this isn't always easy. I think one of the major tools plants depend on is operator knowledge. It's like, oh, I remember the last time I was hearing the squeaky noise, it was because of this. There are various tools that can help you define this meaning. A big one many people use are training tools in SCADA. So it's not just raw numbers, you can start to see patterns and things like that. One problem with these, oops, I jumped ahead. One problem with the many tools like that is it still is not zeroed in enough to uniquely define the meaning. So for example, two operators could be looking at the same graph and come up with two completely different answers as to what that chart is telling them.
And I want to jump in here and just say, Ryan is a data scientist. I'm the operator. I gave him express permission to use that joke. So it's like it's been vetted by the operators because it's true. And then, so you've gathered your data, you've derived your meaning, and now you need to communicate, right? Now what? We've extrapolated some sort of operational goal or desire, but as operators, I mean, we typically rely on shift work, and shift work requires pretty careful coordination for the continuity of operations, right? Everything that you're going to do affects things upstream, it affects things downstream. And so being able to pass the information that you've, the plan that you're thinking in your head, you need to be able to pass that off to your counterpart, to your supervisor. We need to just effectively communicate these things to ensure safe and effective treatment of water. And then the next thing we need to do is, right, we've told everybody we're going to do this thing. Now we need to go out and do it. We need to act, which is pretty straightforward.
Yeah. Once you've taken the actions, you then need to monitor the results. So you've talked about what you're going to do, the operators have taken action, and you want to make sure that what you expected to result from that action is what actually happened. And that leads straight back into the next day. You're gathering data again, and the whole process repeats.
And so, I've lost my notes here. And so the operational cycle is straightforward. It is simple, but we still wanted to set about improving the process. How do we strengthen our ability to make these decisions as a group, make these decisions as individuals? And one of the things we wanted to do, let me just skip ahead real quick here. Let's see. So we asked ourselves, how can we strengthen this process? How can we strengthen the operations cycle? And with that in mind, we set out a couple of goals for ourselves. And one of the things we wanted to do was reduce subjectivity. Some aspects of wastewater treatment are more objective than others. And when that's the case, we wanted to ensure that data was driving those decisions. We wouldn't be removing the operator from the process, but rather giving the operator the tools that he or she needs to make the most informed decision possible. Another goal was we wanted to remove failure points. So again, we're working as a team, but even the best of teams have cracks, and that's just the nature of being human. And so while our job is to meet regulatory compliance as efficiently as possible, sometimes there are multiple ways to achieve that goal. And so we thought, well, part of removing failure points would be to develop a tool that helps standardize the response to challenges or changes in water quality that could potentially fill in some of those gaps or cracks. Lastly, we also wanted to improve accountability. Whether you're frontline staff or a department head, just curious, or just a curious citizen, the status of the plant should be readily discernible and easily digestible. This is both accountability externally and internally facing, both to the public and internally within the team. And so, how do we do this?
Yeah, so here's the new process. You might notice it looks a lot like the old process. And the thing is, we're not trying to reinvent the wheel here. We're just trying to add computer emojis to it. So you see the operator is still critical to every step. We want to augment the operator's ability with automated tooling. So I think another thing that has been valuable is when we're looking at tools and technologies, trying to evaluate them both in general, but also with respect to this process as sort of a rubric to think about which parts of this cycle is the tool going to help us augment. So some examples of that we talked a little bit about this before, gathering data. Yes, you're gathering data with your eyes and your ears, but where you can, let's also gather data automatically. So SCADA systems have been doing this for a long time. Relational databases are something we're going to talk about as a way to organize this data. More and more IoT devices are coming onto the scenes with smart cover and things like that. And looking at tools to help us derive meaning. So yes, we're going to continue relying on our gut and on our experience, but maybe we can augment our tools with a little bit more context that help us say whether a specific piece of data is normal or abnormal. Alerting tools are a little bit in this category of helping us. It tells us what sense to make out of the data. And then another thing that I think the city of San Luis Obispo has done really well is exploring new ways to communicate. So for example, Microsoft Teams has become a part of their communication. So just, yes, we're still meeting in person where we can. Yes, we're still using texting and things like that, but there are new tools on the scene to help. So those are just a few examples of how we might augment this process.
So that operational cycle, it's developed to answer this one question, this one root question, which is, how is my plant doing? And so we've all had those morning meetings, right? Ryan just mentioned morning meetings to answer how's it doing. And, you know, you'll have people say, oh, well, the plant's running great. So-and-so, such and such, did some weed whacking, right? But wouldn't it be cool if we could come together and discuss this question with a singular standardized metric, like animation 1, like 95.8. So this was our goal. We said, hey, we've got the tools, we've got the idea, we've got the ability to generate these algorithms and these automatic analyses. So let's see if we can't set out and build this tool to help our team more effectively and communicate the answer to this root and fundamental question.
Yeah, so we set about that goal, and then we started to talk amongst the team and think, well, how can we come up with a metric like that quantifies how the plant is doing? And Patrick came up with this idea of health scores. It's an algorithm that's really pretty simple. I'm going to walk you through it. Right from the beginning, we wanted operator buy-in. We didn't just want to kind of drop a grade on people. Who knows how they would react to that. So Patrick gathered up the team and started to brainstorm on what sorts of parameters should feed into an algorithm that gives your plant a score. So they started out with breaking the overall plant into 4 different unit processes. I think this is a pretty common practice, and the lingo around these processes had been in place for years already, so it worked within systems that the operators were already experienced with. Within those that breakdown, we then asked, what are the key parameters that we're already tracking that define the health of this particular process? And so they came up with things like temperature and alkalinity and TSS and other parameters like that. Then here's where the operator knowledge really came in, is asking what is normal for these parameters. And we wanted to solicit feedback because, you know, normal may vary from year to year, or it may vary seasonally or things like that. And so we were really relying on that institutional knowledge to tell us, for example, the temperature should only vary between 28 and 38 degrees C. So we established an upper and a lower bound to define normal for each of these parameters. And lastly, we gave each one a weight. That reflects how important that particular parameter is to the process. Then to turn this all into a score, it was pretty simple. We just said, if your parameter at any given moment is within those upper and lower bounds, then you get points equivalent to the weight that we've assigned that parameter. And if you're outside of those bounds, then you don't get the points. So you can add them all up per unit process. You can get a score per unit process, and then you average them all up to get a plant grade.
So I do want to pause here because that was kind of really the meat and potatoes of the presentation, or not. That's how the thing works. And so I know we're gonna have some time for Q&A at the end of this thing, but obviously feel free to type questions into chat if you need anything repeated, or if you have any ideas, or if you're already using something like this at your plant. I know we'd love to hear it. So be active in the chat, and we'll respond as well as we can. But this idea for a standardized metric was first explored at the WRRF during a pretty widespread plant upset in late 2020. And Ryan mentioned that we tried to get operator buy-in initially because we didn't want to leave anybody behind, and that was really kind, because change management is hard and change is hard, but it wasn't actually the case. The initial concept was to assign each unit a grade, and so you can see that grade here. This is version 1. It was built in Excel, really long if statements, and here's just grade A, grade B for, or grade A for unit 2, grade B for unit 3, because it was unit 3 was awarded 80 points, yada yada. And the idea was to have this objective score to fortify that operational cycle. And while the proof of concept worked, it was, hey, I can manually change the entries that I'm adding into Excel and have the grade fluctuate. It the initial feedback that I got from the operations group was an interest in the just straight up listing out the key performance indicators and the associated ranges, but not necessarily the health score, the algorithm itself. The grade, it seemed like the grade had connotations of school or schooling and education, and nobody wants to be like, oh well, my unit's running at a D. And so it was met with disinterest, and even in some cases hostility. This was, nope, this isn't, this can't work, this isn't going to work, this is terrible, this isn't how you operate. And so we altered it a little bit, recognizing that change management and syntax is important. It was like, okay, well, rather than having a grade, we will develop version 2. And rather than calling it a unit grade, we're going to call it the San Luis Obispo Water Resource Recovery Facility Statistical Process Control Charts, or SLO WRRF'soperational for short. And that's when we started generating some buy-in with the world's longest acronym. This was one of the reasons this took off, was because we actually, this was built inside of the UI of our database. And so it no longer required manual entry of data into Excel. The data was already here, it was already collected, and it was already automatically populating every single day. And so a user could come in and see, so here's, if we're looking, let's look at digester 1 influent total solids. We've got that green line there, that's going to be our upper lower control limit. The red line's the lower control limit. You've got the weight, you've got the points awarded based on where you're sitting within that process. And so that's when we moved away from the grading for the soft bits with change management on the operators, and it was also automatically updated. So the technical bits were getting a little bit more refined. And so the downside was that it was pretty slow. It crashed the program frequently, and honestly, it just started to reach the limits of my ability to develop any kind of robust tool. Enter Databrook and version 3. So this is version 3 of our overall plant health. We ditched the acronym. It didn't actually generate any buy-in. Nobody said SLO WRRF'soperational but me. So this is version 3, and we're going to get into this. Ryan will walk us through the different components that help build this tool, and we'll walk through a case study of how we're using it. But overall, we've got these different levels of visibility. So looking up in the right-hand corner, we've got a 94.2% current overall health of the plant. and then a stacked bar chart in the lower left corner, and then just to the line graph just to the left of that, that's the plant's health over time. Lower left corner is a stacked bar chart with the various healths of the different unit, and a breakdown of each unit health in the lower right. So we have these different levels of visibility and different levels of engagement. This was a robust, fast tool that this is when the operators took notice. This is when they said, oh yeah, this is it, I'm in.
And it's interesting working with that pushback, trying to sort out, like, is this concept wrong? Are people not going to like the idea of a grade at all? Or is it something about this particular implementation that's causing us trouble, that it's too much overhead to manually update the numbers or things like that? And that's a battle. I don't know if there's a clear answer to how you work with that. Like, sometimes you just need to keep pushing ahead. Sometimes there are early signs that something's not going to work. But in this case, it started to come together.
And I guess on that, Ryan, I'll mention that we have taken a sort of spaghetti against the wall approach. This isn't the first tool that we worked on collaboratively. This is not even just versions of plant health. We worked on a couple of things that were built and just didn't go anywhere.
Mm-hmm. Yeah,
right.
For the trial and error.
Yep.
So yeah, that screen that we just shared is something that anyone with some technical expertise should be able to set up at your plant. I'm going to walk through the specific details of how it was implemented, and you're welcome to reach out to us if you want additional information about that. So basically, it comes down to these 4 components. There's a relational database, which hopefully many plants already have in some form, and I'm going to talk a little bit more in detail after I go through the summary here. So there's a relational database, there's a Grafana dashboard, which gives us the visualizations. There's a concept of statistical process control charts. And then there's those health score calculations, which we already talked about a few slides ago. So the relational database, Microsoft SQL Server is a great option that's probably installed at many utilities. Postgres is a really cool open source, meaning totally free version. Regardless, if your data journey is starting out in Excel and you're wondering where to go from there, definitely the relational database is a good next step because Excel will eat your data at a certain point in time. Grafana. So this is where all the pretty stuff comes in. Grafana is an open source tool. It's completely free to use for commercial use or for individual personal use. It's web-based, so you can load it up on any tool that has a browser. You can pull it up on your phone, on a tablet, on your desktop. And what it does is it just makes it really easy to create really visually pleasing dashboards. You can create these trends, you can create bar charts and gauges and various things. It does take a little bit of technical chops. You write a little bit of database querying code and things like that. So it's not totally drag and drop, but it's much easier and faster than trying to build this stuff from scratch. Also, just the user interface, the interaction with Grafana is so fun. It's so fast. You can zoom around really quickly. It's just quite a good tool. Statistical process control. So this is a concept that's been around for a really long time. It's been used in manufacturing, and many have suggested its usage in water and wastewater treatment. Some plants may be implementing it already. The basic concept comes down to trying to manage your processes using statistics to help. And specifically, statistics help us figure out what is normal and what's abnormal. So the technical way that you're supposed to do this is taking a certain date range, checking out the parameters, variance and standard deviation over that range. And then you take 3 times that and you define your lower and upper bounds from that. And that statistically means that something like 99.9% of the time, the data should be falling within those boundaries. And if you go outside of that, that means either it's that random 0.1% of the time that happens, or there's some reason that your process shifted it into that space. And that's when you're supposed to start paying attention. another key piece of these control charts is just the visualization. So I think this is a really nice addition to the trend lines that many people have on their SCADA dashboards, is just to visualize these lower and upper bounds, because it helps give anyone, even non-operators, walking by and looking at the screens, they suddenly have a bit more context as to what is normal and abnormal. And that helps derive meaning. That's step 2 of the process. It helps tell you what's going on rather than just a chart floating in space. So with all of that, this was the final product. And we already shared a little bit. Patrick talked about how we start at the high level with our overall score, and then we start to drill down. So I'm going to play this short video, and you're going to see how we start with the high, then we have the individual unit processes, and then we have individual trend lines with those SPC charts. Let's see, there we go. So we're going through the plant. Here's influent information. Here's unit 2 with those red lines marking the upper and lower boundaries. Here are the detailed processes for unit 3, unit 4, and unit 5 and effluent. So that's what the Grafana dashboard looked like. Just a quick bit about the architecture here.
Hey, Ryan, do you think we could pause for just a second? Jeffrey Brown asked a question about Grafana. He says, how can we expect to have long-term support with a free product, and how does Grafana stay in business? And I think those are really good questions. And so maybe you could talk a little bit about what open source software is, what it looks like, and then maybe we'll start to roll out version 4 that might answer some of the other aspects of that question.
Yeah, totally fair question. Open source, I can understand that there's a little bit of discomfort of projects that people are just working on in their free time, and you know, what if something sneaks in some bad bit of code or something like that. But it's turned out to be fairly reliable over time. That you know, organizational structures just pop up around these open source softwares, and they end up being fairly, well, many projects fail, yes, but the ones that succeed end up being fairly well supported. And now we actually rely on open source software for many things in our everyday lives. Like if you have an Android phone, that's based on open source software. Or the Postgres database that I mentioned before, that backs many, many different platforms out on the web. And so it's turned out that these projects can be pretty reliable, and Grafana is one that has kind of risen to the top. Often they do have some corporate sponsorship that helps them stay alive. Grafana has an enterprise version that you can pay for, and that helps you get additional support for it. But they also have this free version if you want to go that route. And you asked about support, and I would say that with the free version, you are a little bit on your own to try to figure it out. So that's kind of the trade-off, but you can always upgrade to the enterprise version.
Except that typically with these types of open source software, there's a massive online community that's dedicated to ensuring that the tools are used and used effectively. And so I know multiple times I've gone on to the Grafana discords and just asked questions, and there are people from all over the world who are jumping in to help me with any problems that come up.
Yeah, good question. Thanks for that. So to get a little bit technical for the tech folks in the room, Grafana could be stood up really easily on premise. It's just hosted on an application server and then pointed to your relational database, basically. We went with a little bit of a more complicated approach. This is the cloud hosted approach, because moving to the cloud, it starts to enable a lot of new power, like being able to view these dashboards from wherever you are. Now, there are risks associated with moving to the cloud, but we found kind of what I think is a pretty clever way to reduce those risks, which is the software that runs on top of the relational database that was already installed at San Luis Obispo can generate nightly emails that get emailed to people that you can review the next morning to see how the plant was performing. Well, we created one of these reports, and instead of emailing it to a person, we emailed it to a little script that we built in the cloud. And that way it was able to receive the email, parse apart the report, save it into our database, and the next morning the Grafana dashboard would be updated with the latest data. So that was just a very low risk and easy way to set up this cloud integration.
Yeah. So when you hear easy, this was a pretty organic process. This path that we started on to develop these dashboards. One of the, getting back to our goals at the beginning of this process, one of the other things that we wanted that we didn't mention was a tool that can integrate daily into the operations team and help us get more out of our existing tools, rather than just saying, okay, well, we need X, Y, or Z. We're going to go out and purchase an additional piece of software, pay all the licensing, and then use maybe 10, 15% of its functionality. So we wanted to take a look. We took an inventory of what we had. We wanted to make the most of it. And this cloud hosted premise with the nightly email was the way to do it. And additionally, due to the organic nature of the thing, if there are any IT people in the room, cover your ears, because this is the way to get around them. You can uncover your ears now.
Okay, so that's it for the nerd stuff. Patrick, I think you got a case study you can talk about here, yeah?
Yeah, okay. So that's the how and the why that we built this tool, and now we can look at some of the real world functionality and how we've integrated it into the operations space. Let's see. So here we are. It's June 6, 2021, and it's funny. So Ryan and I put this presentation together for the Tri-County seminar out in Las Vegas, and I think a couple days after we put this presentation together, we hit 100% for the first time, and that was a huge celebration, which was cool. But here we are, June 20. But if we showed you some software of the SLO WRRF running at 100% all the time, you might be understandably skeptical. So, but nonetheless, we now have this objective score. We're at 88.8%. And like I said, it was a huge celebration when we hit 100%. And it has honestly become a little bit of, let's get that first animation up on there. So it's become a little bit of a game. Here's one of our operators recognizing, just calling it out, saying, hey, I recognize that my unit isn't running well. I'm going to place our cogeneration unit back into auto so that he produces as many kilowatt hours as possible so that his unit score goes up. Arguably, he's going to do that anyways because that's his job and he's an operator. But making your unit score goes up gets you a response with a smiley emoji. So this is this current health. That's our highest level of visibility. Then we'll jump down into the second tier of visibility, which is broken up into each of the units, broken up with their KPIs aggregated into a score. Unit 3 is our activated sludge portion and the sort of heartbeat of our plant. So we'll dive into that one. We'll focus on that 82%. And so now we're in that third level of visibility. And typically this is only the unit operator that's getting involved in this level of granularity. The others are, maybe a director is saying, okay, cool, my plant's running at 90%. The supervisor is saying, okay, each of these units are doing X, Y, or Z. And then an operator or the chief operator is looking at this level of granularity and like, okay, well, what specifically do we need to do to make sure that we maintain the highest level of water quality? And so here we are looking at a couple of our KPIs. You can see our upper and lower control limits in these charts. It's important to note this is data over time. And so, because trends are important. And so this gives you the view of the trends, but the score itself is relying on a single data point. And that's going to be the most recent data point that's available to the algorithm, which is the rightmost data point in the graph. And so that in mind, I think all of our eyes are drawn to this nitrified effluent alkalinity right here in the middle. You can see that we've just dipped below that lower control limit. And this is getting back to June 6th, 88.8%. Here's one key performance indicator that's dropping below our lower control limit. And so we have operator Tyler. He says, hey, my unit isn't running great. I'm going to highlight that in yellow just so that everybody knows that I'm not at a green 100% or 90 plus. He's calling out why his unit is running poorly. And that's first thing he does every single morning. He walks in, he says, here's the date, here's my unit score, here are the things that are dragging it down. I'm gonna go through, I'm gonna hit my rounds, and then once my rounds are complete and I've got a really solid grasp on how my unit is running, I'm gonna make the operational decisions that I need to do to increase the health of my unit. And so right there, less than 2 hours later of seeing that low nitrified effluent alkalinity, he's gonna bump up his caustic dose to ensure that he has that alkalinity to carry him through the rest of the plant. So here we are, June 9th. Just a couple of days later, we flatlined for a little bit, but you can see one of the cool things also in Grafana is you can add these annotations. And so this line that's straight up is Tyler saying, hey, I increased my sodium hydroxide set points, and flatline for a day, and then bumped right back up above our lower control limit. Animation 1, we're at 93.3%. So it took a couple of days. This process is, it takes time, but this was a clean and efficient and objective way of meeting that water quality indicator.
Yeah. So with that in place, revisiting those objectives that we set out at the beginning of how to improve our process, want to ask, how did we do? So reducing subjectivity. Having this metric does help give us just a single measure, and we don't pretend to say that 95% accurately represents exactly how well the plant is doing, but it's a number. It's just a measure. It goes up and down, and we can pretty confidently say that yesterday we were doing worse than today or something like that if that metric goes up or down. So it has been helpful for reducing subjectivity. It helps remove failure points because those steps 1 through 3, the collecting data, deriving meaning, and whatever the third step was, communicating about the meaning, are all helped out by this tool. We now have this metric that we can talk about. And it helps us improve accountability, because if someone's process starts to lag and they say they're going to take some actions, well, we're checking this every day, and we can see, hey, did you actually go take that action? Because the score didn't go back up, or maybe if you did take that action, maybe there's some other things we still need to look into if our score didn't go up. And lastly, retaining institutional knowledge. I think that we've managed to embed at least a little bit of the operational knowledge into this tool by getting that buy-in from the beginning and incorporating that into the scoring.
And here's just a great illustration of a photo that was taken in 2007 on the top, and a photo when I was first hired at the WRRF on the bottom. You can see that institutional knowledge retention is pretty, it's apparent that it's passed along. We still got the blue shirts, we still got the sunglasses, and we still got the mustaches.
All right, so that was V3, and that was a fairly successful rollout. With any tool that you that comes, stock, there are a lot of things that it'll enable you to do quickly, and then at a certain point you get to the edges of what it's designed to do, and you want it to do more. And so we just wanted to kind of flash this V4 that we're playing around with. This is a custom development, and it just kind of draws a little bit of attention toward, draws more attention toward when processes are going out of control, and also it gives you a helper for figuring out your scoring system. So let's see, we're at 11:40. Patrick, do you want to keep going on the PowerFront? maybe do that for a couple minutes, or do you think we're ready for questions?
Is this presentation till 11:45 or noon?
You can go to noon. We had cut the other ones off at 50 because we had something behind, but we can go all the way up to the noon hour.
Okay. Then yeah, Ryan, that unless anybody has any questions right now, we're happy to take them now. But we will be transitioning a little bit into away from water and wastewater and more to power consumption.
I do have a couple questions
Yeah.
that I think will be helpful here. One is, have you noticed any specific parameter that most often affects your overall rating score?
That's a good question. And off the top of my head, no, I can't say that we do any. So we have weights on each one of these. All indicators aren't weighted equally, right? If they're in there, they're important. But then there's the regulatory importance, the super important stuff, which is the regulatory stuff, and then there's the less important process control stuff. And so if a and we also have a section that's dedicated just to our recycled water. And if we have to supplement, if we're out of parameter on for any reason, if we have to supplement with potable water, that's going to drop that score off a cliff, because we don't want to obviously be putting potable water into a recycled water tank. But no, we don't actually track that. That's an interesting question though. And I can find out. I can get back to you.
Okay. Another sort of related question is scenarios of if you were to change, say, a specific parameter, X amount of points, how does that impact the overall score? And various scenarios like that, so we can, where you can kind of see, it kind of help test the validity of the ranking number, because you can see how these things can fluctuate. Any thoughts on that?
I like where your head's at. That's a great idea. And it starts to get a little into, maybe you guys have heard about digital twins. Some of the biggest companies and biggest facilities are trying to set up these digital twins where you have a software copy of your plant, essentially, where you can play with these parameters. We were a little inspired by that. We don't think you need the full artificial intelligence and things like that to just start using software to get you useful metrics. And so that's why, the algorithm's simple enough that we just kind of walked through it here. But I don't know, Patrick, that we have tried that, but I think that we should, that you could put it into an Excel chart and you could start playing with those values to see how it affects your score. And you could start to run scenarios of, well, what happened? Like we saw alkalinity trends really low the other day. What would happen if that happened again in the future, combined with this other parameter going in this direction? Those what if scenarios, I think, would be really cool to explore.
That would, yeah, and I can see how that would take place. Just start making and I think this gets back to either O&M manuals for some of the new plants, but it also gets back to that institutional knowledge. So sitting down with a group of operators at a plant and saying, well, what are my ties? What are my relationships between each one of these parameters? If my nitrified effluent alkalinity goes down, not just how do I fix it to get it back up? What processes are affected downstream? That's interesting.
Yeah, you've given us a good idea.
All right. All right. Any other questions? I want to encourage the audience to put any other questions they have in the chat, and we'll deal with them as they come up. But for now, we can move on.
Sounds good. So that was the main kind of first thing that we explored were these health scores. And that's one of the, Patrick did mention there was a bit of spaghetti on the wall, trial and error, but those health scores were something that really seemed to stick and become part of the operational process. So with that came, this infrastructure. We now have a database. We have Grafana, which enables us to very quickly create new dashboards and graphs and stuff. And it's cloud hosted, which means we can start to look at new opportunities to wire in data to a single system. Open data is becoming a bigger and bigger thing. Many companies are opening up access to data that used to be walled off, or you had to hire an expensive integrator to try to bring different data sources together. And that's becoming less and less of a need. So it's much easier to wire in new data sources. And we started to think about what else could we do? So Patrick identified this green button program for energy.
So, and it was, so we found this, the question arose within not just the utility, not just at the WRRF, not just in the utilities department, but the city as a whole. One of the questions going around was, how much power do we consume and when, and how do we best track it? And we had a lot of different ideas going around, a lot of different pivot tables and monthly huge CSV downloads. And when we stumbled across this small little thing down in the PG&E port, we are PG&E customers. Down in the bottom of one of their portals, there was a green button, download my data button. We started looking at this green button initiative and found that it's a standard for sharing electricity data. And most utility companies in California, including PG&E, are on it. And so we took this idea of having this automatic analysis and real-ish time energy consumption data and being able to roll that out to the rest of the city, certainly within the utilities department. And so we took it to IT, said, hey, IT, this is something that we'd like to do. And they said, no, we don't have a developer on staff, which is fair. And somewhere along the way, the city of San Luis Obispo and Databrook formalized our agreement with a memorandum of understanding. And so we said, well, we don't have a developer on staff, but we have an existing relationship with a software developer in this company, Databrook. So I pitched the idea to Ryan. I said, hey, Ryan, I know you guys are focused on water and wastewater analysis and solving water problems, but a huge part of our industry is, I imagine most municipalities, your water and wastewater sectors are one of, if not the largest draw of power in the city. And so it made sense for us to sort of lead the charge on this. And so we've been rolling through this, for the last 4 or 5 months?
Yeah.
And so we're going to go into kind of what that looks like with some tools that had to be built and then some existing tools that should look familiar to you.
Just a real quick of how we did it. So you can log on to PG&E. I imagine many of you are PG&E customers, or as Patrick said, any of the utilities in California are all part of this program. And so they want to make this data available. You can log on, you can download a one-time extract of the last several years of data. And then the tricky part, which we were able to wire up, was this live updates that every day PG&E publishes a bundle of your data from the night before. And we've built a function that can consume those and load it up into the dashboard. So we get real-time energy updates down, well, relatively real time. Unfortunately, they only give you that data in the last 24 hours, but the data then, once you get it, is 15-minute granularity. So very detailed data of where your energy is going.
And so this is a whole new data set that's available to us. And I guess it's worth mentioning that if we're thinking about power consumption, granularity as a spectrum, on the one hand, you've got, and the easiest, and what we were doing, we were going physically to the meter and recording that number and finding the daily difference every single day. So we had a one-time shot of here's how much power we consumed over the last 24 hours. And then on the other side of the spectrum is these new smart MCCs, these new smart motor control centers that are hitting the industry, where you're going to start getting real time information off of every single draw. Every single motor is going to be reporting out its power consumption every 2, 3, 4 seconds. And so this is somewhere in the middle. This is, Ryan mentioned we're in 15-minute intervals, but once we get it into Grafana, we can start aggregating it however we want. We can't get less than 15 minutes, but we can get more than 15 minutes. And so on the top here, we are looking at the water resource recovery facility. On the top, this is our information of the past year aggregated by month. And so that's just sitting there's bar chart is what it is. Down below, we now look at that same time frame. Grafana's got a time slicer in it, and so as you slice time, it's going to affect every single visualization that you have stood up. So this second one with just the green bar chart, that's aggregated by day. You can see that one that's, let's see, sort of mid to late February. I think we all remember that big rainstorm that hit California at the beginning of the year. That's the INI that is in our collection system hitting the plant. So we had to consume a lot more power in pumping and aeration. On the left, that pie chart, it's kind of hard to see in the static form, but if you, let's say you were to hover your mouse over that, let's see, what's that big orange one, 39%. You would see that 39% of our power is consumed winter off peak. So we have two things that are going on here. We've got power consumption over time, and then time of use, our rate code that's overlaid. So we've got winter off peak, summer off peak, summer on peak, winter super off peak. And so that's all our, that has to do with our billing data. That's going to be either expensive or less expensive power consumption. And that shows up down below. Not super helpful when you're spaced out over the course of 12 months. So I zoomed in a little bit on that bottom graph. So in the main top chunk, you've got that lowest graph that has the yellow lines that are bouncing up and down. This is what it looks like when you're zoomed in a little bit. You can see the differentiation between cheap and expensive power.
So where we are in this process, just kind of set the stage, thinking about those first two steps, collecting data, deriving meaning. We're still in the spaghetti against the wall phase on this. So we are now collecting data. And what Patrick just touched on is kind of a couple of different threads that we're exploring of, now that we have the data, well, what does this mean for us? Well, you can see wet weather events in your energy usage by day. That's kind of cool. And there might be something there that we can do with that. Or there's this time of use exploration that when we're using energy at some parts of the day versus other parts of the day, it just costs us more. And so that's another thread we can look at is how can we start using this data to start to optimize reducing costs, reducing energy usage during certain times of the day.
And so this is a different dashboard, again, built inside of Grafana, but we're still playing around with different ways to interact with this new data set that's dozens of millions of rows long. And so this is, here we're looking at the energy consumption of our water treatment plant. And this is power consumption over the time of use overlay. And you can see, so if your goal here, if your goal of the water treatment plant is to reduce your energy bill at all costs, you can pretty easily see, you can make the argument for shifting the high energy use to lower cost tiers, right? But then there's the soft and operational decisions you have to make. Well, that's easy enough to do, but how are you going to attract the talent that's going to work shift work from 5 p.m. or I'd rather 9 p.m. to 4 a.m. when energy is cheapest. So while we might be able to see some operational decisions that could take place, there's a lot of other stuff that these graphs aren't able to show, like people being able to spend time with their families.
So given the time check, I think I'm just going to go ahead and skip to the last slides, Patrick.
Yeah, go ahead.
So, oh yeah, this one was kind of cool. Okay. Yeah, thank you for letting us share some of these stories. We just love this stuff. So if you guys are, if any of these caught your ear, feel free to talk to us afterward. These are our contact emails. And if there's any more questions before we wrap up, I'm happy to answer them.
Well, thank you, Ryan and Patrick, for this great presentation and sharing your exploration. Love the idea of just wanting to be able to make better decisions. The more information you have, the better decisions that you can make. And so we'd love to hear, and I'm gonna drop a plug here for you guys coming back later after you answer some of the questions. You say, okay, this is the data, then what does it mean? And so I love to hear how this translates some time out. And so maybe we can revisit this topic at some other point. So I'm just dropping that into you guys' head. So any other questions that anyone might have, we want to give you an opportunity to ask that now. And if you do, I'm just going to tell you just to unmute yourself and ask it, and avoid the topic for the sake of time. Any other questions from anyone? All right. We've placed the SurveyMonkey link into the chat. And so we love to hear from you, your comments, and your on our SurveyMonkey. And you also will receive this, as we said earlier, in an email form as well. So feel free to complete that. So if there's no other questions, I don't see any. I don't see anyone unmuting or typing or have sent in a question. So I just want to give now Ryan and Patrick some final words that you'd like to share. Oh, here's coming in.
This is Jeffrey Brown. I do have a quick question.
Go ahead, Jeff.
How come your SCADA system couldn't have shown that same graphs?
Which one is that? The power consumption or the SPC stuff?
Any of them. I mean, it seems like a lot of SCADA systems have that same kind of dashboard capabilities today.
Yeah, it's true. And so I had mentioned, let's just focus on the energy one for now. I had mentioned that the spectrum, right, and the Grafana and the API that PG&E allows is right in the middle. We are in the middle of an upgrade, and slowwrrfproject.org. There's a plug for that if you are interested in learning more about our project. When our new SCADA system comes online in 18 months or so, we will have we are getting smart MCCs. We will have that real-time monitoring of our power system. This was something in the intermediate, and it's also, and we had a meeting yesterday with one of our sustainability analysts with the city. This goes beyond goes a bit beyond water and wastewater. We have our entire city interested in their power consumption. And while the utility side of thing has SCADA, most other buildings don't, and it would only be PG&E that's monitoring their power. And so this is kind of a robust approach to power monitoring.
Jeffrey, perhaps you can share with us which SCADA system do you guys have, and where do you work?
I work for Alameda County Water District. We're actually migrating to a new system here in the near future. We're going to be migrating to Ignition. We're migrating away from OnSpec. We've had them for 25, 30 years. So it's time for us to do something a little different.
Okay.
Yeah, Jeffrey, we'll be joining you in Ignition in about 18 months. It looks like a phenomenal program.
Yeah.
That's great. All right. Ryan, any final words before we close for today?
Wanted to say thanks again, and please feel free to reach out to us. We don't bite, and just love talking about this stuff. So thanks again.
All right. Patrick, anything?
Nope, that's it. Thank you, Robert. Thank you, Michael.
Well, we appreciate you guys being here with us today and appreciate all the audience and everyone. And please complete the survey. We'd like to hear from you. We will be having contact hours given out to the presentations that are approved. And so you can look for that in the email format when we get to the place to send that out. But again, I want to encourage you to complete our survey and also to attend the other presentations of our training buffet this year. There's one more for today at 1, and then we have 3 presentations tomorrow. So other than that, enjoy the rest of your day. Hope to see you again. Take care, everybody.